Now second problem on higher order differential equation. Solve the differential equation d cube minus 5d square plus 8d minus 4 into y equal to e power 2x. Observe this one. First two problems I am explaining. If the last q of x is if it is in the form of e power ax, then how can you calculate the particular integral? Means we are covering the problems particular integral as well as complementary functions, different type of complementary functions. Now in these problems, these are the very important problems. By observing these problems, we can solve the remaining problems also. For every model, we have more models are there. That's why on each model I am explaining one or two problems. Now the above differential equation, it is in the form of f of d into y equal to q of x, where f of d equal to d cube minus 5d square plus 8d minus 4. Q of x equal to e power 2x. Now, if you want to solve this differential equation, already I told you every higher order differential equation, it contains two parts, complementary function and particular integral. Now, first of all, I will calculate the complementary function. For the calculation of complementary function, you need to consider auxiliary equation f of m equal to 0. Means replace d by m equal to 0. Means wherever d is there, in place of capital D, you write small m. M cube minus 5m square plus 8m minus 4 equal to 0. This is our auxiliary equation. Now you solve this auxiliary equation by synthetic division, or directly you can use scientific calculator also. How to enter this equation already I explained you. Now you write the coefficients of m cube, m square, m and constant term. I am writing coefficient of m cube is 1, minus 5, 8, minus 4. Then by synthetic division, you have to start with 1, because when you are substituting in place of 1 m, if you are substituting 1, it becomes 0. That's why I am trying with 1. 0, 1, 1 into 1 is 1 again, minus 5 plus 1 is minus 4, minus 4 into 1 is again minus 4, 8 minus 4 is plus 4, plus 4 into 1 is plus 4, minus 4 plus 4, the last term should be 0. Then this can be written as, it satisfying, 1 is satisfying this equation, means m minus 1 is a factor, m minus 1 into m square minus 4m plus 4. This is the last term is constant, the middle term is m square coefficient, the next term is middle term is coefficient of m, the next term is coefficient of m square. Then m minus 1 into m square minus 4m plus 4 equal to 0. That implies m minus 1 into, again you can factorize in the form of m minus 2 whole square equal to 0. Therefore, I got the roots here, m equal to 1 comma 2 comma 2. Here observe this one, the roots of the auxiliary equation very clearly. One is one different root and 2 comma 2 both are equal roots. Means I explained you, some roots are different, some roots are equal. I gave you the formula. For the different root, we are writing c1 into e power x. For the equal root, c2 plus c3x into e power 2x. This is the formula. I explained the technique. If the roots are different, if the roots are different and equal, then this is the formula. Yp equal to 1 by f of d into q of x. This is nothing but particular integral. The general formula of the particular integral is 1 by f of d into q of x. This equal to, I am substituting f of d value here, d cube 1 by d cube minus 5d square plus 8d minus 4 e power 2x. When you are substituting the coefficient of x to directly in place of d, the denominator part it becomes 0. That's why what I will do, I will factorize. Already I got the roots, according to those roots I am factorizing here. 1 by d minus 1 into d minus 2 whole square into e power 2x equals to, here observe this one, I got in denominator two factors, one is d minus 1 and other one is d minus 2 whole square. In d minus 2 whole square, if you are substituting the coefficient of x is 2, then it becomes 0. Means like that which factor is 0, you have to identify. Means in both factors, the second one is 0. Means the factor whole square is 0. Means for that purpose, the power is 2 is there. That's why directly the answer is x square by 2 factorial. If the power is 3, means x square by 3 factorial. If the power is k, then x power k by k factorial. Like that you have to write. Means when you are substituting 2 here, the second factor is 0 and the power of that factor is 2. Therefore, I am writing here instead of for that 0, x square by 2 factorial into 1. Again in the remaining factor you as usually you substitute here. 2 minus 1 means 1 by 1 into e power 2x. Like this you factorize and substitute it. If it is 0, then power of that one is x power. Suppose d minus a whole to the power of k is there. When you are substituting coefficient of x is, if it is a, if it is 0, the answer is x power k by k factorial into e power ax. Already I discussed this technique in the general formula. Therefore, the particular integral yp equal to x square by 2 factorial into e power 2x. Therefore, y equal to yc plus yp means complementary function plus particular integral. The answer is c1 e power x plus c2 plus c3x into e power 2x plus x square by 2 factorial into e power 2x. Now, this is the general solution of the above differential equation. And suppose instead of e power ax, means I got I have taken in the both the problems e power 2x. Suppose if it is e power 3x, the coefficient of x is 3. Now instead of a power x, they are sometimes they are asking indirectly. Means instead of e power x, they are writing cos hx. Means cos hx means you convert cos hx in terms of exponential function. Cos hx equal to e power x plus e power minus x by 2. This is the formula while calculating the problem. Now if it is sin hx, e power x minus e power minus x by 2. This is the formula. Then instead of cos hx, you write this formula and as usually you follow the method of e power ax.